Not doing beeps. All right, so today we're going to be looking at rectangles. Today is Tuesday, February 6th, 2024. And we're going to be looking at notes over rectangles. Our objective today is we're going to review the definition of a rectangle. We're going to learn its properties. And then you should be able to determine segment length and angle measures in given rectangles. Okay? So the properties of rectangles, it's a parallelogram. Okay, it's a parallelogram. We talked about that kind of yesterday. We had the one, is it a parallelogram? And we saw all four angles were 90. So because our opposite angles were congruent, we said it is a parallelogram. Okay? So since it's a parallelogram, it does have all those parallelogram properties, meaning my opposite sides are congruent and parallel. My opposite sides are congruent and parallel. My opposite angles are congruent. My consecutive angles, do you remember what goes in that blank? My consecutive angles on the same side. They equal 180 when I add them together. The geometry word for that is they are what? Supplementary, very good. And then the diagonals bisect each other, cut each other in half. So if the diagonal is 10 units long, then it's divided into 5 and 5, right? If it's 25 units long, it's divided into 12.5 and 12.5. Does that say anything about the diagonals doing anything to angles? No, it just they cut each other in half, right? It has nothing to do with the angle in that corner, okay? All right, so in addition to those regular old parallelogram properties, it also is going to have its own things that make it a rectangle. The one is the one that you tend to remember from middle school when you learn rectangles, and that is that your consecutive sides, they may not have referred to them as consecutive sides, are, what's the relationship between these two sides that are right next to each other? How do they hit each other? At what type of angle? At a 90-degree angle. We say perpendicular, right? So my consecutive sides are perpendicular. You can use the symbol if you don't want to write out the whole word. You can always just use the symbol. And that means all our angles are how many degrees? 90. They're all 90 degrees. They're all right angles, okay? So that one that I have marked, those two consecutive sides are perpendicular, so I have 90. These two consecutive sides are perpendicular, so 90. These two consecutive sides are perpendicular, so 90. And lastly, these two are perpendicular, so 90. Okay? So that's one of the main components that, oh, this is for sure a rectangle, in addition to all those parallelogram properties. Okay? The other property a rectangle has that's different from just your everyday parallelogram is your diagonals. Not only do they now cut each other in half, but they are also now congruent to each other. Again, if you want to use the symbol, you don't have to write out the whole word. You can use the symbol. Okay? So if I draw my diagonals in, those two total lengths are going to be equal. Remember in yesterday's PowerPoint, when we looked at it, we had one that was like pink diagonal and one was a purple diagonal. We saw the purple one was much shorter than the pink one. In this case, they're both exactly the same length. Okay? So if I look back at diagonals bisecting each other, they're still going to do that. They're still going to cut each other in half. So what that means, if I cut two segments in half that are both the same length, all four of those little pieces now will be exactly the same size, because it's two segments that are the same length that are both being cut in half. So if one is 20, the other is 20, which means they're both divided into 10 and 10. Okay? Those are the only new properties that we get when we get a rectangle. We get all those parallelogram things from yesterday, and then we get these two new properties. Our angles are 90. And the diagonals now are divided into four little equal pieces. Notice I still haven't said anything about the diagonals and angles, okay? We haven't said anything about what diagonals do to angles. All right, so here's a common type of problem. We're going to do about 5 of these today, where it's going to tell you some information about a rectangle, and you're going to have to find something, okay? Sometimes for some of us, the most challenging part is just drawing the rectangle. I know that sounds weird, because you're like, oh, I can draw a rectangle, okay? There's my rectangle. It's drawn. When you label it, you have to be really careful that you follow convention when you label the quadrilateral, because the way they give you the letters, the R, S, T, U, the order is what? Important. Important. Very good. So you have to pick a corner to start with. I almost always go the top left. That's just what I do, but you could pick any corner. And then from there, you have to pretend like when you're little, if you ever played that like hot lava game and you couldn't like walk on the floor, you have to kind of pretend you're playing the hot lava game as you name your quadrilateral. You have to walk along the edge. You can't go into the center of your figure. Miss Bishop. Yes. No problem. Okay, no problem. Bye. Liliana, they need you in the office and they said to bring your elevator key. All right, so I have 2 options only where I can put S. I can either put it over to the right, or I can put it down right underneath R. Me personally, I always go clockwise. I don't know why. That's just what I tend to do. So for me, I'm going to put S there. Then the T, again, you can't fall in the lava. So you can't walk, even if the diagonal's drawn in, you can't go inside your figure. So you have to put the T now, has to go under the S, and then the U. If you get that T and the U backwards, you're going to get things in your picture wrong, okay? So that part's super important. So there's my rectangle. We have diagonals intersecting at V. When you have a U and a V in the same picture, please make sure you can tell the difference between your U and your V. Some of you, your U's and your V's look very similar, okay? So make sure you can tell the difference between your U's and your V's, okay? And they should all be capital letters. I know that U looks a little sus, but it's the font I chose. Okay? All right. So now let's look at the next sentence that they've given us. RT is 2x plus 13. So that's the whole negative sloping diagonal. And US equals 4x plus 1. So that's the whole positive sloping diagonal. And what did we say about our diagonal lengths in a rectangle? They equal each other, right? So RT is going to be equal to US. RT will be equal to US. Okay, so then we just do substitution. RT equals 2x plus 13, and US equals 4x minus 1. And now we can solve for x. You're going to have 2 minutes. Put the value of x on your whiteboards, and then in 2 minutes, we'll all see if we have the same answer. I'm sorry. About 2.5 minutes. Like with your partner, make sure you both got the same answer. If you didn't, talk through it. One minute. Seconds. 45 seconds. 5, 4, 3, 2, 1. Show me your answers. It looks like we all have x equals 7. That is also what I got. X equals 7. You may not have solved it exactly the same as I solved it, but as long as you got to x equals 7. Now, is that the answer to this question? Why not? Right, it says find US. I found x, right? So I still need to find US. US is 4x minus 1. So in my 4x minus 1, I need to substitute in the 7. What is 4 times 7 minus 1? 27. Very good. 27. I don't know the units, so I just wrote the word units after it. Okay? Remember, your diagonals are equal to each other. If you know one, the other is exactly equal to it. Okay? So RT, if it asks me then to find RT, it should also be 27. So if you want to check your work and see if you did it correct, you could plug the x into the 2x plus 13 and get 2 times 7 is 14. And 14 plus 13 is also 27. So just kind of a way you could check to see if you have the right answer. Okay, let's go into the second example. Quadrilateral JKLM is a rectangle with diagonals intersecting at N. I'm going to stop there. Let's draw the picture. So we have a rectangle. We're going to name it JKLM. So you're going to pick one corner to put your J in. And from there, you're going to go either clockwise or counterclockwise. You cannot zigzag across your picture. I always go clockwise. So I'm going to put my K there, my L underneath it, and my M back underneath the J. My diagonals intersect at N, so I'm going to draw those in and put my N. And then let's read about the expressions we have. The measure of angle MJL equals 2x plus 4. So you can trace on your picture to see where MJL is. MJL is the bottom piece of the upper left-hand corner. I'm going to label that with 2x plus 4, because that's what it equals. Then KJL, let's see where that is. Again, if you trace it, you can find it. KJL is going to be that upper piece of that same angle, 3x plus 1. Okay? So when I look at the blue angle and I look at the orange angle, how do they relate to each other, do you think?
They have the same diagonal line.
They're created by that one diagonal. But have we learned anything about what the diagonals do to angles? I know diagonals cut each other in half. And I know diagonals have the same length. So I know lots of things about how long a diagonal is. But has anything told us what they do to that angle? No, right? So I can't just assume anything about what that diagonal, how it's dividing up that corner. But what do I know about that corner? It's a right angle, okay? So I know together those angles make up how many degrees? 90 degrees. So we have to think all the way back to Unit 1B, like September, and angle addition postulate says if you have two adjacent angles, which these are because they share a side and the vertex, if I have two adjacent angles, then together, together they're going to make a whole angle, which in this case is 90. Okay, so my 2x plus 4 plus my 3x plus 1 is going to equal my 90. Okay, take 2 minutes, see if you can find x. So we're solving for x. Combine your like terms. Isolate the x term. Get rid of its coefficient. 2.5 minutes. We'll put our value for x on our whiteboards. About 1 minute left. Ten seconds left. All right, show me your answers in 5, 4, 3, 2, 1. What did we get? I see a lot of 17s. Let's see. Yes, x equals 17. You can give yourself a round of applause. X equals 17. But again, just like the last problem, that's not what this one's asking me for, right? This one's asking me to find the measure of angle KJL. So KJL is that orange angle. So I'm going to take KJL, 3x plus 1, and I'm going to substitute in the 17. What is 3 times 17 plus 1?
52.
How much?
52.
52? 52 degrees. If I were to plug the 17 into the blue angle, how many degrees should I get?
45. Wouldn't it be like 90 minus?
I should get 38, right? So if I do 2 times 17, that's 34. And 34 plus 4 is 38. So again, that's another way we can check our value for x and feel confident that we have the right answer. It's always nice if you can do something to make yourself feel a little bit more confident, especially in math. Okay? All right, number 3. Quadrilateral ABCD is a rectangle with diagonals intersecting at E. Let's pause there. Let's draw our picture. So ABCD, we have A. I always choose the upper left corner. You pick the one you like the best. And then either go clockwise or counterclockwise. Do not go zigzaggy across your figure. And my diagonals are intersecting at E. Once you have your picture drawn, then you can look at your expressions. AE is 3x plus 3. EC is 5x minus 15. What is going to be true about the blue and the orange pieces here? They're going to equal each other, right? Oh, and here, look, I'm trying to find the whole thing AC, yes? Okay, so I know that my two pieces should equal each other. This time we're going to be asked to find AC. So I want you to go all the way through finding X and finding AC. Go all the way to the end of this problem is what's going to go on your paddle. Since you're going to do that little extra bit, I gave you 1 extra minute. You have 3 minutes to find the length of AC. If you're stuck or you're not sure, check with your partner.
So on our boards, you want us to put both answers?
Just AC. On your board, I just need AC on your whiteboard.
How'd you get 16? How did you get it? Yeah. Oh, wait. 18 divided by 2.
35 seconds. You can check it if they equal each other. All right. Oops. Let me see your answers. What did you get for AC? Paddles up. I'm seeing 60s, I'm seeing 30s, I'm seeing 18, but mostly I'm seeing 60s. Let's see what I got. I feel like I might have had a mistake. No. X equals 9. So then when I plug a 9 in there, 3 times 9 plus 3 is 30 for AE. So that's just that piece. And then EC, 5 times 9 minus 15 is also 30. That's how you know if you made a mistake. If those two sides aren't equal, you made a mistake, right? But then AC, the whole length, is going to be the two half diagonals together. 30 plus 30, my whole length. Those of you who had 60, good job. You have it correct. If you didn't have 60, see what you did wrong, okay? So those of you who had 30 on your paddle, you forgot you're going all the way across. It's two half diagonals to make one whole diagonal. If you had 18, that means you were saying your whole your half diagonal was, you forgot to plug it back in. So you knew to double what you got, but you forgot you had to plug it back in, right? So you were on the right track. Everybody was on the right track. Some of you just got off the train a little too early, okay? All right, let's look at number 4. Number 4, quadrilateral WXYZ is a rectangle with diagonals intersecting at V. The measure angle XWY is x plus 3, and the measure angle YWZ is x plus 15. Find the measure angle XWY. You're going to work this whole problem from beginning to end with your partner. You have 4 minutes. About 3 minutes left. Alright, you should have found X by now. You have 2 minutes left. Hopefully you've at least found X. Green thing. The answer.
What
60 seconds. Remember, I'm looking for the final answer. I'm looking for the final answer. Not the value of X, but the final answer. Thirty-five seconds. Show me your answers in 3, 2, 1. Answers. I'm seeing mostly 39s and a couple of 36s. Let's see. We should have our picture and our work. So if you had the 36, you found X, right? But we are trying to find XWY, which is the blue angle. So then you plug that 36 in and add 3 to it, right? And you get 39. Again, you can check your answer if you take 36 and add 15 to it. You put it in the orange angle. Mine did it in orange. Then when you do 36 plus 15, you get 51. And you can check that 51 and 39 do make 90 degrees in that corner. Okay? But I'm glad that everybody at least knew not to set them equal. You did add them together and set them to 90. Everybody got at least to X correct. All right, number 5. Quadrilateral CDEF is a rectangle with diagonals intersecting at G. So I'm going to draw that rectangle. Pick a corner, any corner, put your C there, and then from there go around the figure either clockwise or counterclockwise. I always go clockwise. Do not zigzag across your figure. My diagonals intersect at G. It's a weird looking G, but it is what it is. Okay. Once I have my figure drawn, I'm going to see what they've given me. D to G equals 7x minus 2. The distance from point D to point G is 7x minus 2. And then the distance from C to E is 12x plus 6. So this one's an interesting one because this time they didn't give me 2 things, like they didn't give me 2 angles that I can see make 90, right? They didn't give me 2 whole diagonals. They didn't give me 2 half diagonals. They gave me 1 half diagonal, and they gave me a whole diagonal. Any idea how I could figure out what the value of X is? Yes, Remy. Double the half diagonal, right? Because 2 half diagonals makes a whole diagonal. 2 half diagonals makes a whole diagonal. 2 half diagonals makes a whole diagonal. So then we just substitute in, right? So 2 of the DG values is going to equal 1 of the CE values. And so we substitute in. What's the first thing you're going to want to do on this problem? Distribute, right? All right, find the length of DF. So don't stop at X, go all the way to the end of this problem. You have 3 minutes. Find DF. You're trying to find how far is it if I start at point D and I walk all the way to point F.
So we're looking for DF and DGs and T2s. That means you see 5. Yeah, because DG is 1, so that means it's
About 2 minutes left.
So what's the problem? What's the problem? What's the problem?
The equation?
Yeah.
All right, you have about 1 minute left.
Which one? Like this? Okay. You just
About 30 seconds. You need to get your answer on your paddle. Seven, 6, 5, 4, 3, 2, 1. Show me your answers. I've got 33, I've got 66, I've got 26, 66, 33. Mostly 66s, a couple of 33s and others. Let's see. So you should have gotten your x equals 5. And then when you plugged it in to DG, the blue piece, you got 33. But it didn't ask me for that. It asked me for the whole thing all the way from D all the way to point F. So if 1/2 of that diagonal is 33, that means the other half of the diagonal is also 33. So the whole thing is 66. So again, if you got 33, you were on the right track. You just got off your train too early. Okay? So I'm glad to see that most of us were on the right path. We just need to make sure we go all the way to the end of the trip. Okay? Another way you could have done it is you could have said, I know those two diagonals are the same length, so if I plug in the 5 into the 12x plus 6, 12 times 5 is 60 plus 6 will also give me 66. That diagonal is 66. Both the diagonals are 66. So you could have done it either way. All right, the last thing we're going to look at is solving a rectangle. Anytime you're asked to solve a shape, there's a weird sentence, solve a triangle, solve a rectangle. It just means find all the things, find all the angles that are possibly present, find all the side lengths that are possibly present. Okay, so they've given me that it's a rectangle, so I know my angles are 90 in the corners, and they've given me that one side length is 5 inches, and they've given me that an angle at the diagonal intersection is 120. Okay? So probably the easiest thing is if I know one side is 5 inches, what else do I know? The side across from it is 5 inches, right? So that's an easy one. Okay? That's my rectangle, that's my parallelogram property. And then if we think all the way back to unit 1B, do you remember what we call these angles? Vertical angles, and we know they're the same. So if one's 120, the other's 120. Do you remember what we call these two angles?
Vertical.
No, vertical were the 120 and the 120. So two green angles. They make a line. They are supplementary. When they're adjacent like this and they make a line, we call them linear pairs. Think back. Linear pairs, but they are supplementary. So if one is 120, how big is the other one? 60. And then you can either use the same concept of a linear pair right next door, or you can use your vertical angles with the 60, right? Those both have to be the same. So that takes care of a lot so far. Okay. Let's see what else we know. We know if this is a rectangle that all 4 of those pieces are exactly the same. Okay, so now look what I'm going to do. I'm going to focus instead. We spent literally like 3 months on triangles for a reason. We need to remember all those triangle skills. Okay, this triangle has 2 congruent sides. What kind of triangle is it? It's isosceles, right? Which means I know its base angles at the bottom of those congruent sides are the same. So if that vertex angle up there at the top is 60, can I find the other 2 angles? How many degrees in the whole triangle?
180.
180, and I've already used 60, so how many are left for the bottom 2 angles? 120, but, right, we divide it out, and we get that each of those bottom angles is 60. So not only is this isosceles, it's actually equiangular, which means it's also what? If all the angles are the same, it's equilateral. All of those sides are the same. Oh, we know what one side is. One side is 5. So how long are all those pieces?
5.
They're all 5. So I've got that triangle taken care of. I know all its angles are 60, all its sides are 5, and guess what? I have another triangle just like it on the other side. Right? That's another isosceles triangle, so it's going to have congruent base angles, which will have to be 60, which means this is another equilateral triangle, so all those sides are 5. Look at this. All right, let's see. What should we look at next? We still don't have quite all of our angles, so let's try to see if we can find those other angles. How many degrees in the whole corner? 90. I've used 60. What's left for that itty bitty piece up at the top?
30.
Okay, 30. Where else am I going to find a 30?
On the other side.
On the other side, and the bottom, and the other side of the bottom, right? Those are all going to be 30 because I've got those, all the other pieces are 60s. Have I missed any angles? I think we got all the angles, right? The only sides we're missing now are the lengths, the whole top and the whole bottom. Again, we spent 3 months on triangles for a reason. When I look at this triangle, there's 2 things I notice about it. I notice it's a right triangle, where one side is 5 and the other side is 10. So I could use Pythagorean theorem to find that missing side using a 5 and a 10 as the hypotenuse, right? Or I also notice that it's a what kind of 90 triangle? Look at the angles.
30, 60,
It's a 30, 60, 90 right triangle, where my x is my short leg, which they gave me. My short leg is 5. My hypotenuse is 2 times that, which we already found. It's 10, right? And that just happened to work out for us. And so all I need is that long leg, which is x square root of 3. How long is my long leg? I don't even need a calculator. How long is the long leg on the bottom? If my short leg is 5, and my long leg is the short leg times the square root of 3. 5 square roots of 3. Now, if you use Pythagorean theorem, you're not going to get 5 squared root of 3. If you put that in the calculator, you're going to get the decimal equivalent, and you're going to have to round it, and that's okay. Now, if that side's 5 squared root of 3, then we also know the top is 5 squared root of 3 because opposite sides are congruent. And we have found everything in that triangle. That's lovely. It's completely solved. There's nothing we're missing in that triangle. Okay? All right, so just a reminder, today what we did is we reviewed the definition of a rectangle and its properties. And you should now be able to determine segment lengths and angle measures in a given rectangle. You're going to show me that you can now do that by completing your independent practice 7.3. Yes? Tomorrow, 7.1, 7.2, 7.3, I'm going to check those to see if you have them done. They're going to go in the grade book tomorrow as one grade. Okay? For tomorrow. Yes.